In this video, I want to have a look at maximum and minimum points. So a function might have a turning point that's a maximum or a minimum, but it might only be a local or a relative maximum or minimum. It might not be the overall maximum or minimum value that that function takes. So the name we give to those overall maximums or minimums is actually a global or an absolute maximum or minimum. So that's looking at the entire function and finding the biggest or the smallest value that the function takes within a given domain. So often when we get questions like this, we will be given a limited domain that we need to consider the function for. So we need to consider the value of the function at those extremities as well as at the turning points. So for example, in this one we've got here, we have stationary points here and here that are local minimums, and we have a local maximum here. So there are stationary points, and we find the nature of them, they're minimums or maximums. So this local minimum, that minimum stationary point, is also actually the minimum value that that function takes on through that whole domain. But this maximum here isn't the maximum or the global or absolute maximum, because our function continues up here. So we not only need to look at the stationary points, but also at the values of the function at those extremities. So in this question, it asks us to sketch the function and state its global maximum and minimum within the domain. So our function is y equals x to the power of 4 minus 2x squared minus 1, and we're looking at the domain from x is between minus 2 to 3. So the first thing we're going to do is to find the stationary points and determine their nature. So we're going to differentiate that function. So we'd have y dash is equal to 4x cubed minus 4x. Now to find the stationary points, we're going to set that equal to 0. So we'll have 4x cubed minus 4x equals 0. We'll factorize out that 4x as a common factor. And we can see that this is the difference of two squares. So that would become x plus 1, x minus 1. So that's going to give us our three stationary points at x equals minus 1 from this bracket, at x equals 0 from this section here, or at x equals 1. So that's given us the x coordinates of our stationary points. Let's find the y coordinates. So to find those, we're going to substitute these x values back into the original function, and we would end up with y equals minus 2, y equals minus 1, and y equals minus 2. So now we need to determine whether these are maximums or minimums, or points of inflection. So we'll draw up our table of values. We'll have our x values, the value of our first derivative, and this is going to be quite a large table. So we've got our minus 1, 0, 1, and something on the other side of that as well. So we know at those points our first derivative is 0, so it's horizontal. And now we need to pick other values in there. So let's pick minus 2, minus a half, and 2. So we're going to substitute those values into our first derivative. And we'd end up with minus 24, 3 over 2, minus 3 over 2, and minus 24. So then drawing our little diagrams down the bottom, we've got a negative, a positive, and a positive goes here as well. Then we've got a negative, which makes this one like that as well, and another, hang on, that one should be positive, 24, sorry, and our positive. So we know that we have a maximum and two minimums. Before we start sketching this, we're also going to find the value of this function at the extremities. So we're going to, just down here, write at x equals minus 2. So we're going to substitute minus 2 into the original function, and we would end up with y equals 7. And at x equals 3, if we substitute that into the original function, we would end up with 62. So now we've got enough information to sketch our function. So the first thing I'm going to do is draw in the boundaries for our domain. So I'm going to put 3 here. We'll just draw in a dotted line there to show that we're only looking in this region, and we've got minus 2 here. Right, so now within there, we've got, we can put our extreme values in first. So at x equals minus 2, y is equal to 7. So we'll put that about here. So that means our curve is going to pass through this point here. At x equals 3, it's equal to 62, so we'll just put that all the way up the top. This clearly isn't to scale, but that's okay. And then we can put in our stationary points. So we have at 0, it was at -1. So we've got -1 here. So we have a stationary point here, and that we know that that's a maximum. And then we had at 1 and -1, the value of that was -2. So -2 would be down here. So we'll have minimum values here and here. So then we can join that whole thing up to draw our curve. And down here, through that point, and up the top here. And then coming down to this minimum and up here. Alright, so now from that, what we can see is that we have a global maximum up here. So that was at this value. And our minimums, our global minimums, are actually our 2 local minimums, our 2 stationary points. So we just need a final statement. So we'll write, therefore, global maximum of y equals 7. Global maximum of y equals 62. So I've circled the wrong one here. That should be this one that I've circled for that point. At x equals 3. And global minimum of y equals -2. And that was at x equals plus and minus 1. So we found our global maximum and our global minimums within that domain.